positional isomers. They have different position of loop and functional groups, or the multiple bonds, or the substituent groups in the same skeleton of the carbon atom. It means that if you have different position of the substituent groups, or different position of the double bond, or you can say a functional group attached to the main carbon chain, then they will be called as positional isomers. Let me take here an example. If you have a CH3 CH2 CH2OH, this is called as a 1-propanol, propane 1-ol, right? So we have a OH group on the carbon number 1. You can draw another structure, but you have a the same carbon skeleton, but the position of the OH group is different. It is present on the second carbon. So we have propane 1-ol, and this is the propane 2-ol. So propane 1-ol and propane 2-ol, these are the positional isomers because they have the different position of the OH group, right? So this is on the carbon number 1, this is 2, this is 3. Here you have the OH on the first carbon. Over here you have OH, the functional group, on the second carbon. All right. We can take another example of the alkenes. Suppose we got here a double bond between the first and the second carbon here. So this is what we call as a but1ene. You have a double bond between the first and the second carbon. You can draw another structure where the carbon skeleton is almost same. The only thing is the position of a double bond is different. Now you can have a double bond between the second carbon and the third carbon, right? And then these two will be called as positional isomers because you have a position of the alkene, position of the double bond that is different. Or you can write it like this. You have another molecule, CH3 CH2 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 and the chlorine here. This is 1-chlorobutane, and you can have a chlorine on the second carbon also, then it will be called as a 2-chlorobutane. So these are the positional isomers. The position of the substituent group here is different. So 1-chlorobutane and 2-chlorobutane, these are the positional isomers. Let's take few more cases. Again, see here, we got here a methyl group attached to the carbon number 2nd. Over here we have the same carbon attached to the third carbon atom in the main carbon skeleton. So these are actually the positional isomers. Alright, here you have a double bond between first and second carbon. Here you have a double bond second and the third carbon. So again, the position of a multiple bond or a position of a triple bond is different. So these are positional isomers. Now let's try to find the relation between the different structures over here. If you see here, in all the 4 cases, the total number of carbon atoms is the same. That's 6. Alright. What about the first and the second? You got here the 5 carbon atoms here in the chain, and here also the 5 carbon atoms, and you have a 1 methyl group here. So if you look at the first and the second, the basic carbon skeleton is same, right? 5 carbons here, 5 carbons here. The substituent group is also same. Correct? The only difference is that they have the different position of this, this particular carbon. Let's say this is CH3 and this is also CH3. So the position of the methyl is different. So these will be called as positional isomers. So first and second are positional isomers, right? So I'm going to write first and the second. These are positional isomers because they have the different, position of the methyl group, of the substituent group attached to the, the similar carbon skeleton. In the positional isomers, the carbon skeleton is same. Only thing is that you have different position of the substituent group or different position of the functional group. In the chain structure, in the chain isomers, we have different carbon skeleton, right? The carbon skeleton is totally different. So if you compare the first with the third, right? Just compare the first with the third. See, the basic carbon skeleton is different. Here you have 5 carbon atoms in the main chain and one of the carbon as a substituent group. Here you got the 4 carbon atoms in the main chain and 2 different carbon atoms attached to the second carbon. So these will be first and the third, it will be a chain isomer, not the position isomer, right? These are the chain isomers. So you can say first and the third. What is this? What are these? These are the chain isomers. Let's compare the second and the third now, right? The second and third. Again, you see here 5 carbons in the main chain and one of the carbon as a substituent group. Here you got the 4 carbons in the main chain and different substituent groups. So that means second and third, they have the different carbon skeleton, so they will be called as chain isomers, right? They'll be called as chain isomers. So these are not the positional isomers, second and third, right? These are the chain isomers. What about the third and the fourth? Compare the third and the fourth. So you got the 4 carbons here in the main chain and 2 methyl groups attached to it, CH3 and the CH2 here. Here again in the fourth case you have 4 carbon atoms in the main chain similar to this one, 4 here and 2 methyl groups here also attached to this main carbon chain, but the position of the 2 methyl groups is different, right? Here you have the 2 methyl groups attached to the carbon number 2. Here you have the 2 methyl groups attached to the 2 different carbons. It is carbon number 2 and this is the carbon number 3. So this will be called as 2,2-dimethyl butane and this will be called as 2,3-dimethyl butane. So they have the same number of carbon atoms in the main chain and similar groups. The only difference is that they have the position different, right? So I can say the third one and the fourth one, these are the positional isomers because they have the different position of the substituent groups. All right. Now we have to draw the different positional isomers of the dichlorobenzene. You got a benzene and you have to attach 2 chlorine atoms to it. And we know, in a benzene, you can have the 2 substituent groups attached to it at any 2 positions. Correct? You can attach over here a chlorine and then another chlorine at any of these positions, either at the ortho or the meta or the para position. So that means you can have you can have another chlorine, second chlorine at the ortho position or at the meta position or at the para position. So obviously you will get 3 positional isomers of the dichlorobenzene and they will be like this. You can have a chlorine here and the second chlorine at the ortho position or at the meta position or at the para position. So 1,2, 1,3 and 1,4 dichlorobenzene. These are the positional isomers. Now what are the positional isomers of dichlorobutane? Again, butane we know it is like this. Cyclobutane is like this, cyclic structure, and 2 chlorine atoms, their positions can be different. Correct? You can have the 2 chlorine atoms either at the same position or at the adjacent or at the opposite 2 positions. So you can have 3 positional isomers for the dichlorobutane. Alright. Either the 2 chlorine atoms will be on the same carbon or they will be at the 2 adjacent carbons or at the opposite 2. Alright. Write all the positional isomers of the dichloropropane. Dichlorocyclopropane. So cyclopropane is like this. This is our cyclopropane. And now either the 2 chlorine atoms will be on the same carbon or on the 2 adjacent carbon atoms. So it has only now 2 positional isomers for the dichlorocyclopropane. Either the 2 carbon atoms will be on the same carbon or the 2 adjacent positions. Alright. Hope you got it. Thanks for watching the video. Bye for now.